Okay. This is Automotive Electronics Test 7 from Class Manual, Chapter 7. Any sensing wire voltage drops will increase the system voltage by the amount of the drop. Sensing wire voltage drops. Huh? Alright, you got that? Alright. Any sensing wire voltage drops will increase the system voltage by the amount of the drop. Hey, man. What do you think about that? What's a sensing wire? Huh? That's basically true, yeah. What is a sensing wire? What would you call a sensing wire? What would I call a sensing wire?
Last week we had plus, we had minus, then we had sensing wire, and we had a ground wire.
Yeah, so if I've got a sensing wire, are we talking about charging systems? Huh? Think about it now. When you're talking about a sensing wire, are we talking about charging systems? Look at the rest of these questions. Are we talking about charging systems? Okay, so that you got to define what a sensing wire is. All right. Let me show you what we're talking about there. Okay. Like for instance, on our little Ranger alternator out there, we've got a little connector on there, and we've got a big connector on there where the big lug is that goes out to the battery, right? This is the one with that nut on it. All right, so I'm just going to draw this rough. Okay, you got 3 wires. You got another little connector on that one that's sort of by itself, and one of these wires jumps over there. You got me? This one here goes to B plus, and this one here goes to the light. Understand that? So this one, I mean, they may not be in exactly that order, but you got a green one with a red stripe that goes to the light. You got a yellow one that goes to the B plus, and it's a kind of a heavy wire. And then you got a little white one with a black stripe that jumps around. Now this one here is coming off of one of the stator wires. The stator being that winding that's around the outside, and it's reading 7 volts off one of those stator wires, so that the voltage regulator, which is right here, will know whether or not the alternator is putting out. Matter of fact, the alternator can be putting out, and if this wire right here has got a bad connection, the alternator light will be on, because it won't know. Even if the alternator is putting out, you may hook your charger system tester up and see good charging voltage, but if this light right here, if this wire right here is not jumped around there, and not all alternators have that external, most of them got an internal. Okay, this wire coming from the light turns on the regulator. If that wire is cut or if it's shorted to ground, the alternator won't put out. I could cut that wire or short it to ground and send it to a bunch of shops, and all of them would throw an alternator on it and then throw their hands up because they wouldn't know what to do. If you short the light to ground, it's going to burn the light all the time. If you cut the wire, the light won't come on at all. So, Daniel, you remember from the other time, what's the first thing you need to look at if you're checking a charging system problem? I need to know if the alternator light's on. The battery light? If that battery light's not coming on, you better find out why, because that may be your trouble. You got me? If the battery light does not work, you need to find out why before you do anything else. Because the battery light circuit can keep that alternator, that regulator's going to be turned on like any other device, and the voltage coming through that light. That little light on the dash that says battery turns it on. Now there's a little resistor jumping around that light, so in case the light burns out, it won't kill your charging system. This is the sensing wire right here. You got me? Alright, so if the target for this thing, if the target for this alternator is 14 volts, 14.5 volts, let's say it is, so it's 14.5, and it's going to be reading this wire right here, that regulator is. It's also using that wire to feed the brushes, but it's going to be reading that wire. And what if you've got a connector here with some voltage drop? If it's dropping 2 volts right there, then you're going to be reading what? 12.5. All right, your alternator is going to be trying to correct that 12.5 and bring it up to 14.5, isn't it? Okay, and what is it going to do? It's going to fulfill the alternator, and then you're going to look at your charging system voltage, and it's going to be tacking off the chart like 16.5, 17 volts, because it's trying to correct for a condition that's not true. That's the sensing wire. That's what it's talking about. You got me? So the wire that's coming there that it's actually reading off of is the one that you're talking about when you're talking about a sensing wire. So if you've got voltage drop on that wire, it's actually going to change the output of that alternator to the point to where it's going to try to jack the voltage up. Make sure you understand that. We're doing a lot more than just spoon feeding you the answers. I need you to understand what's going on behind all this. You got me? If the output current is greater than needed, system voltage will fall below specification. That's a sort of a confusing answer, isn't it?
Yeah.
I mean, what it is, that's actually false. Yeah. Think about it. If the output current is greater than needed, it's going to run the voltage off the charts, isn't it?
Yeah.
If you're putting out too much current, you're going to have more voltage too. The AC generator's maximum available output increases as rotor speed increases. The faster you spin it, the more it puts out. You got me? All right. Excessive output can be caused by a faulty battery, and that is true. If I got a battery that's internally shorted and it's pulling that voltage down, loading, it'll do that. And that battery can also explode, you know. All right, always, anytime you guys are jumping off a car or doing anything that's related to a battery, if you don't have safety glasses on, you got rocks in your head. That's kind of dumb. If you ever seen a battery blow up, you know. All right, that's almost like a bouncing Betty, you know, and then thing that blows you up, you know. Them things are nasty. You'd think a bomb goes off if you hear one. In a hybrid vehicle, the motor generator recovers heat energy used by brake converting rotational energy to kinetic energy through a system of electric motors and generators. That's a dumb statement, and it is not true. In a hybrid vehicle, you know this little thing right here, you know how I took this little motor right here and I hook that little LED up to it and I spin this little motor and it creates the current and flashes LED. You ever seen me do that? It's just a little electric motor. That's the same thing, only on a huge scale. You got this great big MG2 motor, and whenever it changes the electronics so that whenever you're hitting the brake, a sudden change takes place, and all of a sudden this thing's generating energy. And when it's generating energy to charge the battery, it is hard to turn that motor, and it slows the vehicle down. Craig had and I've got a film of that somewhere in my hybrid school stuff. He had one of those MG1 motors up there, and he had it fixed up so he could flip 3 switches and, you know, energize one set of the windings and another set and then another set. And he says, okay, turn this, and you can turn it real easy. And he flipped one switch and it got harder. And then he flipped another switch and it got harder. And when he flipped the 3rd switch, you couldn't turn it. It was just, well, see, if you apply that to the drive line, the weight of the car is going to be strong enough to turn that thing, and the juice that it's creating goes back into the back. You can look at a scan tool if you drive some of these hybrid vehicles and you're hitting the brakes a lot. You'll see that battery voltage go up on it, like when that Ford Fusion we were driving, it went up like 600 volts on the battery back there because it was juicing that thing up good and strong because you were hitting the brakes a lot. Okay, Technician A says a full fielding test should be performed only if the charging system fails the output test. Technician B says the field windings are constantly energized with full battery current during full fielding. Who's right about that? It has to be both of them. See, what you do there, why would you full field an alternator? What are they talking about when you full field an alternator? If you full field an alternator, basically you're trying to bypass the regulator and you're wanting to regulate. You want to see what the alternator is capable of doing. Is the guts of this alternator capable of putting out good strong charge, or is it not? Something else you can do to see if the field is energized on an alternator is take a hacksaw blade or something and stick it to the back of the alternator, and it should grab a hold of it. If that spinning rotor is energized, a hacksaw blade ought to stick to the back of the alternator, and then at least you know that the field is energized. You got me? All right. So, but anyway, when you full field it artificially, and you need to check on each vehicle how to do that. You know, some of them it's really difficult to do. On others, it's not. On that alternator on that old Chevy out there, you can actually stick a screwdriver through a D-shaped hole in the back of that and hit that little tab on the brushes in full field, it bypassing the regulator, that little electronic regulator. On the 350, you know, on the stand over there, that's the way we used to do it years ago. But if you know that on this Neon, it's got 2 wires going to the alternator. One of them comes from the ASD relay, and the other one's the field wire that's controlled by the PCM. If you short that PCM side of that thing to ground, then you're going to full field that alternator, and it should basically start charging off the charts. If you full field it and you don't get anything, you know, then you need to be looking at somewhere else for your trouble. It may be in the alternator, or you need to make doggone sure that you don't have voltage drop between the output terminal on the alternator and the positive side of the battery. How many of you guys in here have done a charging system voltage drop? And how do you do that, Daniel? Big terminal on the alternator, positive terminal on the battery, right? It should not drop over how much? Half a volt there. It shouldn't do over there. Anywhere it's dropping voltage is going to be hot. It's going to be smoking. And that's also going to keep it from working, you know. Okay, now then, let's see. The charging system of a vehicle equipped with onboard computer controlled charging system is under charging. Now, onboard computer controlled charging system is most of the vehicles out there now. A lab scope is connected to the ground side of the alternator field, indicates a 90% duty cycle. What does that mean?
90% on, 10% off.
It's 90% on it's on 90% of the time. It's only releasing it 10% of the time, so it's almost full fielded. Technician A says the alternator may need to be replaced. Technician B says the onboard computer may need to be replaced. Who's right about that? That's A. You're not going to replace the onboard computer for that. It's actually, if you're looking at, if it's looking at lower voltage than it's shooting for, the target voltage is not able to be reached, and it's almost full fielded the alternator. The alternator is probably weak. How many of you have heard a alternator whine because of a bad stator winding? You know how the ceiling fan goes, you know how they buzz? That's an electronic hum that comes from that resonance in those coils. And on those, an alternator will do that too. It'll whine. And then there's a button on that you can push on that thing. It says Stator, and it'll tell you if it's good or bad. But I always follow up with a scope. If you hook a scope up, you know, you ought to see a nice even ripple. If you see a ripple, usually whenever I see a bad one, I see a bunch of nasty stuff like this. You know, if you hook the scope up. You know. If you don't know how to hook the scope up to an alternator, it ain't that hard to do. You just basically gonna hook up to the hot side coming out of the alternator with your scope and just see what that pattern looks like. You got me? All right, now then, let's see. Technician A says before performing the voltage output test, a visual inspection and preliminary check of the charging system should be done. Technician B says voltage output test will indicate if the charging system is working properly. See, sort of. And I will tell you this, you're not going to be able to fix a charging system just using a voltmeter. That's just not the way it is. Number 9, a 100 amp AC generator produces 105 amps all the time. Full fielding it produces 105 amps also. What does this indicate? A, the regulator is running on the AC generator full field all the time. B, the AC generator is faulty. C, the output wire has excessive resistance. Or D, the drive belt is slipping. There's only one of those that can be right. For whatever reason, the regulator is running the AC generator full field all the time. That is not always a regulator problem, though. I worked on a motorhome one time that had a doggone a problem with it charging too much. It was boiling the battery and, you know, putting out about 17, 18 volts. But it would do it. It would do it when you gave it when you applied the throttle. It would do it, right? Okay, so applying the throttle spins the alternator faster, doesn't it? Does it not?
Yes.
All right, now what does that do to the output when you spin it faster?
High.
Goes up. All right, so I said, well, this seems to charge normally whenever it's idling, but when I give it the gas, it goes off the chart. And so what I'm going to do is I feel like that's probably a bad regulator. Well, tell them to come in here for a second. Let me see what they need me for. All right. Hey.
Hey, I got a problem with my car.
Uh-huh.
And I was wondering if you can work on it.
I can. Come back in about 30 minutes, okay, when I'm through in here.
Just
Okay.
drive it over here.
Well, I mean, come back and talk to me about it in
Okay.
30 minutes. All right.
All right, thank you.
All right. Okay. All right, let me see. All right, now then, what I did was on that motorhome, I got out of there, I pulled the alternator off, and I put a voltage regulator on it. You know, because basically, if it's under warranty, they want you to surgically repair it. They don't want you just throwing an alternator at it. It's like if you got a problem where you need to put a set of rings and a piston, you know, like you don't put a whole set of rings in an engine on a warranty repair. You put rings on one piston. That's the way it was, you know, because they basically are saying they don't want you changing a bunch of parts. That's why they sell rings in single sets at a dealership. All right, but anyway, I says I'll pull this off, I'll put a regulator on, put it back on. It's just like it was. So what do you think's going on there? Think about what's going on. How fast is that alternator spinning? It's got a little bitty pulley. It's spinning really fast. Centrifugal force is causing it to full field itself. I've seen that about 2 times in my whole career. Centrifugal force was causing it to full field when it was spinning up too fast like that. So just be aware of the fact that if you've got one that's full fielding, it may well be something wrong with the alternator itself. Oh, that's so nice. Thank you. All right, there you go. Put that other
Where's
thing
your
on.
credit for your engine now? Put it on your desk.
Okay, all right, that works. All right, now then, what type of voltage is at the back terminal of the AC generator? Yeah, you're going to have DC there. That's the only thing that needs to be there. And you need to make sure, let me hit you with this. If you've got some sensitive electronics that are going kind of wacky, it's not a bad idea to check for AC voltage there in case the rectifier is not quite working right. If there's any AC voltage coming out of that terminal, there may be some issues with the alternator. You understand? You get where I'm going? Most people don't ever think about checking that, but it's important if you got squirrely problems going on. A ground circuit voltage drop test taken on a vehicle's alternator indicates 0.965 volt drop. Wow. Technician A says this could cause a problem with the alternator's field current. Technician B says this could affect the output circuit of the alternator. What do you think about that? That's C. That is C. Technician A says when testing the voltage output, the charging output, if the charging voltage is too high, the charge could be an open field wire from the regulator, or the cause could be an open field wire from the regulator. What do you think? Would an open field wire cause the charging system voltage to be too high?
No.
It would basically cause it not to charge at all, wouldn't it? There you go. All right, and let's see, what was the other one? Let's see, Technician B says a loose or glazed drive belt could be the cause of too high a charging voltage. What about that? Come on, is a loose belt going to make it overcharge? I don't think so. Use your noggin. Why should an AC generator never be operated open circuit? And what it would do there is just basically spike everything out. Now, you remember some people, when you say operate open circuit, you ever seen anybody take a battery cable off with the engine running to see if the engine dies, and that's what they do to check to see if the alternator's putting out? That is not a good way to do that. Not anymore, because you can cook stuff that way, and that's not a good plan. So don't go there, no pulling the thing off while it's running, I mean, you may, it's kind of like I'm always talking about, people say, well, I've done that a bunch of times and I've never had a problem. Well, it's kind of like the Russian roulette thing. Click, click. Hey, I've spun that cylinder all kinds of times and pointed the barrel, and I never had a problem, But the one time you do is really, look what's at stake. You see what I'm saying? Especially with all those electronics, man. You got 40, 50, 60 computers on some of these cars. And all, you do something like that to see if it's charging out in a parking lot. Now all of a sudden a whole bunch of their accessories are offline, and they got this problem, that problem, the other problem, and if you're do it at a shop and they can definitively say if all this stuff was working when it came in here and now it's not, and if you happen to just be careful with that. Don't do that. The charging system of a vehicle produces 100 amps and 12.4 volts at 1500 RPM with all electrical accessories turned on. The charging system output spec for this vehicle is 110 amps. Technician A says the alternator needs to be replaced. Technician B says the electrical demand of the vehicle may exceed the capacity of the charging system. That's going to be B. However, what I'm going to say, I had a 88 Ranger I worked on that I actually put it on my Technical Writer Facebook page. Some of you may have seen it. And this doggone thing, the guy says, I bought an alternator from AutoZone, put it on my vehicle, and a bunch of smoke came from under the dash. And I think that their alternator messed up my truck. Seriously, right? So AutoZone, to their credit, says, tell you what, take it to the Ford place, and if they say that our alternator burned it up, we'll pay for whatever it takes to fix it. And that was fair enough, wasn't it? So I took it up there, and I said, first thing I need is the alternator that you originally bought from them and put on it, because somebody had put the old one back on it, right? And so when they came in on the hook, and we brought it in there, and I opened the hood, and you could feel heat coming off that alternator, the old one that was on it, from 3 feet away. I mean, this thing was blistering hot. And, and if you could put an egg on it, if you wanted to, it was that hot. And I said, okay, I'm going to put this other alternator on here. So I put the other alternator on it, fired it up, and I saw smoke coming from under the dash after a minute. That's interesting. Well, I tracked it down, and there was the wires at the inertia switch had burned up. The little inertia switch, the one that you hit, and it goes, and it turns on the fuel pump. It had burned the inertia switch up, and somebody had bypassed it. And actually run wires past it. And so I fixed that, and I made a good strong inertia switch connection and all that. And then I fired it up again. And I noticed my charging system tester, instead of showing 14.5 volts, was showing 12 volts. Right? And I just kept watching this thing run. I say, well, I wonder what's going on, you know, what the deal is with that, you know, scratching my head on that. And then I'm sitting in the driver's seat, and all of a sudden I see flames under the hood on the right side. And I'm saying, good grief, what is this all about? And I went over here, and the fuel pump relay was on fire. I said, wow, that's pretty interesting. So anyway, I had to fix all of that hogwash. I got a fuel pump relay, I got a connector, I got solder and heat shrink, and I put it all back just like brand new. And then I found out this thing had 2 tanks on it. It was just strange for a Ranger, but it had 2 tanks. And he was trying to run it on the front tank. I noticed when I put it on the back tank, nothing got hot, but I wanted to put it on the front tank, it did. It turned out the fuel pump in the front tank was pulling 40 amps. Literally pulling 40 amps. It's supposed to pull about 8 amps, 6 or 8 amps when it's running. It was pulling 40, and that was enough to heat everything up. The alternator he got from AutoZone was nice and strong and, you know, juiced everything up real heavy. The other alternator had been destroyed trying to pull this heavy fuel. It wasn't strong enough to burn up any wires, but it destroyed itself trying to, you see what I'm saying? But my charging system tester was reading 12 volts because, you know how whenever we load the charging system, the voltage goes down and the amps goes up? Well, on this one here, there was a load test being done by the stupid fuel pump in the front tank. Well, as it turned out, you get me? You know, I mean, the windings were kind of burned up on that pump, and it was running. It was producing fuel, but it was pulling too many amps. That was an anomaly. It was real strange. But all the fire and the smoke and all that was just you know, lots of excitement. You know, and so I mean, you know, seeing the fire under the hood is always a lot of fun. You know, I used to set fire to about 1 a year when I was at the Ford place for one reason or another. Not on purpose, but you know, it just happened. All right. Well, I kept a fire extinguisher nearby, and you sort of get to where you're seasoned. After a while, you know how to grab the fire extinguisher and put it out, you know, without getting too excited. How many output diodes does an AC generator stator with 3 windings usually have?
3.
Does it have 3, 4, 5, or 6? Who says 3? Excuse me? It's 6. It has to be 6. You're not going to have just 3 diodes in an alternator. Oh, I'm sorry. You know how they're laid up? You know how they're laid out in there? All right. See this? Watch this. I got like this. All right. You got that. You got that. You got that. Like that. Notice how they're all pointing the same way? All right. Yeah. And the stator, each one of those is going to be hooked to one of these. Like that? You understand that? Stator's got this part spinning in the middle of it, but it's actually made out of a big hoop. Right that? Okay? And so on one side of this is your negative, and on the other side is your positive. So you got 6 diodes there. That's typical. You got 3 windings, you know. You got 2 different kind of stator windings too. You got delta or Y. You got me? A delta wound stator is like that, and it's still got 3 outputs. A Y wound stator is like that. Got me? You understand that? Delta looks like a D or a river delta. You know, it's like a triangle. Got me? This one right here is a Y. It's like a Y. That ain't hard to remember, is it? Okay. So since it's not hard to remember, remember it. Okay. Technician A says when testing the charging system, the state of charge of the battery is not a concern. Whoa! What a joke. Technician B says the battery must be checked first before checking the charging system, and he is right about that. If you don't have a good strong battery, checking the charging system is downright silly. Technician A says the scan tool may be used to full field some alternators. Are you true about that?
Yeah.
Technician B says a field current draw test indicates if there's a current available to the field windings. What in the Sam Hill is he talking about there? How do I do a field current draw test anyway? You got any idea?
Very carefully.
Well, that's not exactly what I was after. All right, now, let's say I got 2 terminals here, and this one here is B plus, and this one here is actually coming from, it's a switched thing coming from the, I'm drawing a little switch there just because, but it's basically going to be coming from whatever regulates it. Typically that's going to be the computer on most cars nowadays. Alright, so as you all know, here's your big terminal going out, you know, and everything. So we're going to take an inductive pickup, right? And we're going to put it around there, and we're going to read that. Got me? Why do you need field current anyway? Because there's got to be enough current there to create magnetism in that rotor, doesn't there? If you've got a voltage drop in your field, you're not going to have full, you know. And usually this is where you go, what you're supposed to do before you replace the alternator. But most of the time people throw an alternator at it first because that's usually what's wrong with it. And without doing this, and when that still doesn't work, then they're supposed to go checking all this other stuff. But most people don't have a clue what field current is, or voltage drop, you know, charging system voltage drop test and all that. So, and anyway, number 17 is basically going to be a C. What does increasing the regulator field resistance mean? And regulator field resistance mean, number 18. That means less output current is desired. In other words, that's an engineering thing. If you're increasing the regulator field resistance, that means that you don't have to have as much output current. Technician A says when testing the ground side of voltage, the voltage drop should be less than 0.2 volt. Technician B says the total insulated system drop should be less than 0.7 volts. Who's correct about that? That's going to be Charlie. Yeah. Where's the output of a generator created? AC generator. The reason they're calling it an AC generator, you know, and I've actually got into some, you know, semantics contests with people about this, where the J1930 regulation likes to call the alternator a generator. But for the 13th issue of Motor Age one time, I wrote an article about alternators for Vistion, who actually rebuild alternators, and I had to actually submit it to the people at Vistion so they could proofread it before it was published in a magazine, you know, with their tagline on it. And I was calling them generators because that's what I was kind of getting used to. And they says, listen, it's an alternator. We're not going to call it a generator. Well, my deal was, if the PCM controls the field, I'm going to call it a generator. If it's standalone, like the alternator, like the Ranger does, I'm going to call it an alternator. You know, what the hey, you know, I guess. So just keep that in mind. You may see AC generator, maybe you hear it called an alternator, whatever. But where is it created, number 20?
Stator.
It's created in a stator. How is it created, though? We're going to magnetize the rotor, and we're going to spin it inside the stator, and when that magnetic field sweeps across that core, it's going to create that juice. And that boy, can they ever create some heavy-duty juice. How many of you know you can take welding leads and hook them to a good strong battery and put a welding rod in there and weld, just like you can with a welding machine? Did you know that? You can hook a battery up. In other words, to welding cables, like put battery cables on a welder, and you know, hook a good strong battery up, and you can actually lay a bead, just like you were using a welding machine. Well, you know that. You know, if you ever shut your jumper cables together, how it, you know, makes them. You know, if you had a welding rod, you could burn it. Now you'd run the battery down pretty quick, but you could, if you're in a bind and you need to weld something, you could make it happen. You know, you're going to do that. All right, let me see here. Let me make sure that this thing don't shut off here. All right, let me see. I'm trying to figure out this. Oh, here we go. Technician A says regulator is the cause of if full fielding the regulator bypass produces lower than specified output. In other words, if you full filled it and the output is lower than specified, is the regulator the problem? Because you've bypassed the regulator, right? Technician B says, excuse me, a full field test will isolate the problem if it's in the AC generator or the regulator. Typically, B is right about that one. What devices are used to rectify current in an AC generator? Diodes. As we call that, a rectifier bridge, right? And what other device has a rectifier bridge in it besides an alternator? What about a battery charger? All right. Let me see here. What component carries a magnetic field current inside an AC generator? Huh?
Brushes.
What? The rotor. The rotor is what carries a magnetic field current. Technician A says a diode should be tested with a digital multimeter that has a diode setting. Technician B says when testing a diode with a digital multimeter that has a diode test setting, the meter should read approximately 0.6 volts in one direction and 0 when the leads are reversed. Who's right about that? Both of them are right. All right, now let me hit you with this. This is pretty cool. I mean, I've showed this a couple of times before, and I've actually got a YouTube video or two on this. I've got an alternator here, right? I got my big post. Forget about everything except the big post and the housing, right? Okay, I'm going to take my meter, And I'm going to put it on diode test. You're going to click it around there to where it's pointing to the diode test. Let me see that meter over there. Is there a meter there? All right. On this meter, this silly little $10 meter, and I love these little $10 meters because, you know, they don't, it's got a little diode test way down here. And you click it around there like that. Diode test is right there where I got it pointing right now. See that diode test? All right. Now, you might notice that when I touch these leads together, it reads nothing. Well, sort of, but it is, but it's not, because it's going to read some stuff there. Now, this particular meter here is sort of skewed because somebody, you know, hooked it up the wrong way and blew the fuse and all this kind of thing. It works okay for, you know, measuring voltage. It's not going to work good for diode test, so you need one that doesn't have this black X on it. One way or another, I'm going to hook up my meter, my leads. I'm going to hook my red lead here, and I don't have, then I'm going to hook my black lead here. Excuse me, red lead here and black lead here. Got me? All right, and then I'm going to read whatever is up here. And, you know, let's say that I read 6 pin. I'm going to flip them around, and I'm going to read it the opposite way. It should read one way and not the other. You got me? If it reads one way and not the other, does that mean the alternator is good?
Yes. Well, no, not really.
It reads one way and not the other.
Yeah, if it reads the same both ways, or it doesn't read it all both ways, what does that mean? It means the alternator is bad. That's a go, no-go test. However, if it reads one way and not the other, it doesn't mean the alternator is good because there's too much else that can be wrong.
Yeah.
You know what I mean? So if it fails, the alternator is junk. If it passes, you still need to do further testing because that is not the end of all things. You know, when you test the alternator that way, you swap it back and forth. And it's easy to do. The coolest thing about it is you can unhook the alternator from everything on the car, just unhook the wires from it, and you can test it right there where it is. And sometimes you've actually shortened your diagnostic time because if you see that it either reads the same both ways, you understand what I'm saying? I'm going from the big post to the housing with my 2 leads, and then I'm going to switch them. Got me? I'm reading it both ways. If I'm reading the same both ways or 0 both ways, and I know my meters are, you know, trustworthy, then I'm basically looking at a situation where I've got a bad alternator. Now, like I say, you still get to check further if it passes that test. That don't mean the alternator is necessarily good, but just keep that in mind too. There's a lot of tests like that. If it fails the test, it's bad, but if it passes the test, you may not be done. Well, the one exception to that is if you put those hook your test light in series with a fan motor, turn it through, and that thing ever goes out, you know, that you don't need to test anymore for that, you know. And if it never doesn't go out, the fan motor's typically good. That's just usually the way it is. Okay, where are we at here? In a full hybrid HEV, which hybrid electric vehicle, which component is responsible for recharging the 12-volt battery from the 300-volt direct current system?
DC to DC.
The DC to DC converter is what does that. The DC to DC converter. All right. Now then, let me see. Number 26. What tool should be used to ensure proper belt tension? A belt tension gauge. But I've got one of those darn things. But the reason I don't like it is because you may have a lot of space. You know, if you can find belt deflection readings in your shop manual, that's okay. But basically, you don't have to do that if you got a spring-loaded tensioner usually. When in doubt, replace the tensioner, you know, for the most part. And I've got, like I say, I got one of those in there because I'm required to have one, but I've never seen anybody use one. I mean, they talk about it at the, you know, factory schools, but, you know, it's so specialized from car to car that it's just pointless. You can tell when a belt's too tight when it's not. I mean, if it's squealing, don't over-tighten it or you'll burn up bearings. If it's one of those where it's got movable pulleys like some of your Asian cars and all, if you over-tighten that thing when you got a bolt that's moving that pulley, you can destroy expensive components by over-tightening the belt. If you under-tighten the belt on one of these aftermarket belts, it'll start squealing, or it'll be fine to start with, and then it'll stretch, it'll start squealing. You have to tighten it 4 or 5 times to get it tight enough, but you got to be careful not to get it too tight. In what type of stator is one lead from each winding connected to one common junction?
The Y stator.
The Y. Bingo. I prepared you for that question. What's the name of the stationary coil that produces current? That's basically the stator. Okay, number 29. How many pairs of diodes does a full wave rectification require in an AC generator? 3 pairs. The fault indicator circuit is completed to ground in most electronic regulators if there's no output from what component in the alternator? I said that earlier too. Remember, it reads off one leg of the stator. It reads off one leg of the stator, and if it's not seeing the 7 volts there, then it's going to do that. Interesting that it's 7 volts coming off of one of those 3 legs, isn't it? Sounds like a 21 volt system, doesn't it? All right. Okay. Let's see. Explain the purpose of the charging system.
Charges the battery.
Converts the mechanical energy of the engine into electrical energy to charge a battery, right? Okay. What factors affect the amount of current produced? What was this one of the things we've talked about earlier? What can increase it?
Speed of
The speed, that's a good answer. What else? What about the strength of the magnetic field?
Yep.
What about the number of conductors passing through the magnetic field? All of that. The more conductors you got, the stronger it is, right? Think about an ignition coil. You got not many windings, you got a lot of windings, and whenever it collapses, a lot of windings cause a high voltage spark, right? Okay, let me see here. Let me see. What is the purpose of the voltage regulator, and how does it control AC generator output? Whoa. You're having to engineer that. How you gonna do it? It needs to know what the thing's putting out so that it can increase the field. When it increases the field, it puts out more. If it sees voltage it likes, it's got a target. Think about it. Now, you see that ratty old regulator right over there? That's the way they used to be. And those terminals on there are as follows: FRBI. So what does FRBI stand for? Field, R terminal, which is the one that's giving you the charging, whether or not it's putting out. B, which is battery, and then ignition. And ignition being coming through the light, right? So it's coming through the bulb to I terminal. The battery is the one that's sensing what it is that's in the battery, so it'll know what to do with the current. And that's an old electromagnetic thing with coils and points and stuff in it. And they were set up. That's pretty ingenious right there. Seems to me like that would be harder to build than some of this electronic stuff we're using today. You use Zener diodes to build them out. But anyway, that's how that's FRBI. And I had to memorize that when I was rewiring all those forklifts and everything. All right, now let's see. What's the purpose of the regulator test? Oh, and by the way, let me back up. How would I fulfill the alternator on one of those? Got me? How would I fulfill it? I just love a ringing telephone. I love it. Okay, FRBI. Let's see who that is. They'll leave me a message. FRBI. Field, R terminal, battery, ignition. I'm going to fulfill it. I'm going to unplug the regulator. What am I going to do right here to fulfill it?
battery.
Huh? What about this? It depends. On the old Motorcraft regulator, some of the real old ones, they actually grounded the field and it was hardwired to power. You need to find out which one's hardwired. Typically, the field will be hardwired to power and the ground is going to be switched. All right. So if I know that's the way it's hooked up, I'm going to take the field terminal and jump into here. Got me? I mean, that takes the regulator out of the loop. These regulators that are mounted on the fender, I'm just telling you this because it's old stuff, they got to be grounded really good. Don't just plug in a regulator and have it lay in there because it won't work. It uses the ground that it's mounting to feed out to that alternator. All right, you got that. Now then, let's see. What lists the 3 sources of noise and the sounds the AC generator can produce? What's the first thing that comes to mind?
Bearings.
Well, bearings, but what else?
The stator can make a noise.
Stator can make a noise. There you go. Winding. One more. What about a loose belt?
Brushes wouldn't affect that.
But I tell you what, Demetrius's brother has got an Altima that's going. The belt's going, brrr, making all kinds of racket. And another noise that's not here. Those overrunning alternator pulleys can go bad and cause them to make a funky noise. And that pulley is a little cheaper than an alternator. But sometimes you have to replace them. You can replace the whole alternator. It'll come with a pulley. If you look at that alternator pulley and you see one that you can't see the nut, if it's just got like a rubber cap, you know, where you can't see the nut, that's one of those overrunning pulleys. And when you pop that little cover off, you'll see where you got an Allen, you know, typically put in there, and you can put on your impact and spin it off there. Okay, number 36, list the areas that could cause charging system voltage to be too high. Give me one. What about a poor voltage regulator ground connection? Because they can't read good there. That's if you got an external regulator mounted on the fender too. What about defective wiring between the voltage regulator and the AC generator? What about a defective voltage regulator? All of that stuff. Voltage to be too high. Also, if it's full fielding the alternator as it spins up faster, like I was talking about earlier, that's another answer for that.
What did you say number 34?
Which one was? Number 34. Number 34. I might not even have asked that question. What's the purpose of the regulator? Oh yeah, it's used to determine if the regulator is working, basically. Just maintaining the output under load. All right. Anybody got any questions or comments about that?